Hello and welcome to Learn Chemistry with Banke. I trust you are staying safe. Today you will learn about a very special group of elements known as alkali metals. In the last class, we talked about families of elements, and families of elements share similar characteristics and chemical behavior. Today, you will learn about these alkali metals, the characteristics, and the reactions that they undergo. Now, look at these three items. Can you guess what they all have in common? One interesting thing about chemistry is that the items you use every day all have an element of chemistry used to make or produce these materials, from clothing to drugs to food. Each of these basic items have an element in them. For example, salt contains sodium. You know that sodium is one of the elements belonging to the group 1 family. Batteries contains lithium ions. You know that ions are charged particles, right? And banana contains potassium. All these three elements, lithium, sodium, and potassium, belong to the group 1 family, also known as alkali metals. And today we will learn what the characteristics of alkali metals are and the reactions that they undergo. These are the alkali metals in the group 1 family. Note that hydrogen is not a metal. It is a non-metal. And hydrogen is a non-metal. Hydrogen is a non-metal, but it does not belong. It is just placed in the group 1 family for convenience. It only has one electron, right? But it is not a metal. It is just a non-metal. So these elements are the true alkali metals. So what are the characteristics of alkali metals? The first characteristic is that they are univalent. Univalent means that they all have just one electron in their outermost shell. Valence electron. This is the outermost shell for lithium, which has atomic number 3. And sodium with atomic number 11. Lithium has atomic number 3, right? And sodium has atomic number 11. When you draw the shells, this is the K shell, this is the K shell, and this is the L shell. So lithium has just 2 shells, and it has one valence electron in its outermost shell. Sodium with atomic number 11 also has one electron in its outermost shell. So all elements in the group 1 family have one electrons, just an electron in their outermost shell. Also, they are good reducing agents. They are soft and shiny with low melting and boiling points. Elements in the group 1 family are highly electropositive. Electropositive meaning that they readily donate electrons. So they are used in batteries because they can serve as good conductors of heat and electricity due to their electropositive nature. Their electropositive ability is due to the fact that they readily donate electrons, the valence electron in their outermost shell. Atomic radius increases for group 1 elements, group 1 family. Atomic radius, electronegativity, reactivity, these are parts of the periodic properties or periodic trends that we will talk about subsequently. Atomic radius meaning that the size of the elements increases as you go down the group. Take for instance, when you look at lithium, we are talking about the atomic radius, the size increases from lithium to sodium. You can see the difference in size, with lithium having just 2 electron shells while sodium has 3, right? So electronegativity decreases down the group, and the reactivity of these elements increases down the group as well. In other words, lithium is not as reactive as sodium. So I mentioned that lithium is the smallest in size in the group 1 family when you talk about the atomic radius, and the size increases down the group. Sodium is bigger than lithium, potassium is bigger than sodium, and the size of rubidium is larger than lithium. Francium is the largest when you talk about the atomic radius. So the atomic radius increases down the group in the periodic table. Their reactivity also increases down the group. I told you earlier that sodium, for example, is more reactive than lithium, and francium is the most reactive in this group of elements. Let's take a look at the periodic table. Look at the periodic table here. So you see hydrogen being placed there for convenience. It is not a metal. So their reactivity increases down the group. Remember that groups are vertical columns. This is group 1, while periods are horizontal rows. And the focus today is on the group 1 family. They also have distinctive flame colors, which makes it possible to identify them in qualitative tests. They produce distinctive flame colors that makes them easily identifiable in qualitative chemical reactions. So what are the reactions that group 1 family members participate in? Here, group 1 elements react with hydrogen to form halides that can then be hydrolyzed in water to yield hydroxides. Again, group 1 elements react with hydrogen to form halides. This is sodium halide. This is lithium can also react with hydrogen to form lithium halide and up until francium. These halides, when they are formed, this is a sodium halide, for instance. You can also have lithium halide. You can have francium halide. So they combine with hydrogen, and then when the elements react with hydrogen, they form halides that can be dissolved in water to form their corresponding hydroxides, right? So when this lithium halide dissolves in water, you have lithium hydroxide and the rest. And there is a liberation of hydrogen gas at the end of this reaction. Another reaction they participate in is that they react with water to form strong alkaline hydroxides. And these alkaline hydroxides are useful in everyday items that people use to make life easier. For instance, sodium hydroxide will participate in a reaction known as saponification. Right? To form soaps. This saponification reaction is important in production of soaps and detergents that you use to wash your clothes. Similarly, this particular alkaline hydroxide, which is sodium hydroxide, is also used in making bleach. You are all familiar with bleach, which is basically sodium hypochlorite, right? And you use bleach to remove tough stains on your white clothes, right? So alkali metals can undergo reactions with water to form strong alkaline hydroxides, and these hydroxides are useful in making important products that you use at home every day. Now, one thing to note is that the more, for instance, as you go down the group, lithium will react vigorously with water than, sodium will react vigorously with water compared to lithium. Francium will react more vigorously with water also compared to lithium, right? So the higher you go down the group, the more reactive they are with water. It is important to note that you should be careful around these alkali metals because they are highly reactive, because they have just one valence electron in their outermost shell, and they readily donate these electrons so that they can form They readily donate these electrons in reactions to they readily donate these electrons in reactions, and this is the reason they are highly reactive and they can form explosive compounds, right? So you should be careful around them. And that's it today on Learn Chemistry with Banke. Like the video, share it, and subscribe so that you can learn more important lessons on chemistry with Banke. I'll see you in the next video. Stay safe.